Hi everyone, so in this video I'm going to go through the different questions that involve the rice or the ice method. So you can check your answers and you can just go to the different sections of the questions that you're working on. You will find the timestamps in the video description. So here we have 20 moles of ammonia placed in 2 dm cube container. Temperature is given. It's allowed to undergo equilibrium to form nitrogen and hydrogen. So I have NH3 that's going to undergo equilibrium to form nitrogen and hydrogen. So we'll start by balancing the equation. So I put a 2 here. I put a 3 here. Now it tells me that I have 20 moles of ammonia at 2 dm cube. So I have the number of moles, I have the volume, and to find the value of K, I will need concentration of ratio of products to reactants. So concentration is number of moles divided by volume. So 20 divided by 2, that's 10. So I will fit in the chemicals here, and then the ratio 2:3:1. Initially, this is what I have. I have 10 mole per dm cube of ammonia. This is the reactants. So initially you have a certain amount of reactants, and initially the amount of products is 0. Then it says that at equilibrium 2 mole per dm cube of ammonia is present. So at equilibrium I have 2 that is left. So how much has been used up? So it has decreased by 8. Now I'm going to look at the ratio here. So ratio is 2:3. So 2 NH3 corresponds to a change of 8. Therefore, 3 hydrogen will correspond to a change of 8/2 times 3. So that gives me 12. So because these are products will increase. So this is going to be plus 12. Now nitrogen, so 2 corresponds to 8. 1 nitrogen will correspond to 8/2 times 1. So that's 4. So change of plus 4. So 0 plus 12, that's 12. 0 plus 4, that's 4. So K is concentration of hydrogen to cube times concentration of nitrogen divided by concentration of ammonia square. Plug in the values. So this is the answer. Example 3 now. It says that you have 0.2 moles of PCl3 and 0.1 mole of Cl2 in 1 dm cube flask. So because volume is 1, so any number divided by 1 is the same number. So this still supply concentration is equal to number of moles divided by volume. So you can take concentration to be equal to number of moles. Then this is going to produce PCl5. So I have the equation producing PCl5. And then it's asking you for the value of K. So I will need to draw my table for the rice method. And here the equation is already balanced. So ratio is 1:1:1. Now initially, so these are the reactants. So initially you will have reactants, and initially you will not have any products. So initial amount of products will be 0. Initial amount of reactants, this is given here, 0.2, and chlorine is given 0.1. And then it says that the PCl5 was allowed to come in equilibrium, and at equilibrium you have 0.12 moles of PCl3. So at equilibrium, I'm going to have this. So this is going to decrease. So these are reactants. Reactants will decrease, products will increase. So this is the initial, this is the concentration at equilibrium. So what's the change? Change is minus 0.08. So ratio is 1:1, therefore this is also going to be minus 0.08. This is also ratio 1:1, so this is going to be plus 0.08. Remember that products will increase, reactants will decrease. So if you do the calculation, you get these concentrations at equilibrium. Now finding the value of K, K is concentration of products divided by concentration of reactants raised to the power. So this is the value of K. Example 4. So here you have oxidation of NO to NO2, and it occurs in the presence of oxygen. So I'm going to have NO plus O2 giving NO2, and I will balance the equation. So I'm going to put a 2 here and a 2 here, which balances it out. And I'm not given the table, so I'm going to draw my Rice table, and I need to find the value of K at equilibrium. So ratio 2:1:2. Initial concentration. So remember again, concentration is number of moles divided by volume, and it says here volume is 2 dm cube. So concentration of NO will be 0.6 divided by 2. So that's 0.3. For oxygen, this is also at a volume. So here 0.6 again divided by the volume, that's going to give me 0.3. This is the products. So initially concentration of products is 0. Now it says that at equilibrium you have 0.2 moles of NO2. So be careful here. This is the amount of NO2 that you have at equilibrium, but this is 0.2 moles, and this is in 2 dm cube. Therefore, concentration of NO2 at equilibrium is going to be number of moles divided by volume. So 0.1. So this is 0.1 here. So what's the change? Change is plus 0.1. Plus, because this is products is increasing. These are reactants. So reactants are going to decrease. So by how much will they decrease? So we'll do the easiest one. So ratio 2:2. Therefore, plus 0.1, this should be minus 0.1. This one ratio is 1:2. So this is going to be half of this value. So this is going to be minus 0.05. So these are minus values because these are reactants. Reactants will decrease, and this is plus because products will increase. So you do the calculation so that you have the values of concentration at equilibrium, and from this you can get value of K. And as you work it out, you should get the value of K to be equal to 1. Another type of question, here you are given the value of K. K is given. And concentrations at equilibrium is given, but there is one concentration that is missing. So you need to find the concentration of oxygen. So concentration of this and this is given at equilibrium. You need to find the concentration of this one. And when you don't know something, you can call it X. So we know that K is concentration of products raised to the power divided by concentration of reactants raised to their respective powers. So these values are known, but x is this one. Let's say this is x, this is unknown. Let's fill up the equation. So here concentration is given here. So then 3 will be equal to, so concentration for sulfur 6 oxide is this. Concentration for sulfur 4 oxide is this. So sulfur 6 oxide, this is SO3. Sulfur 4 oxide, this is SO2. You have to remember your naming. So SO3, this is going to be 0.18 square divided by 0.12 square times x, which is unknown. You solve, do subject of formula, solve for the value of x. So x is 0.75 mole per dm cube. Now you need to determine the initial concentration of both reactants. So the equilibrium concentrations are known. I'm going to write my equation. I will write my y. So ratio 2:1:2. Initial reactants, you have a certain initial concentration. Let's say this is A, and then oxygen, let's say it's B. And then initial amount of SO3 is going to be 0. And then in the end, you know that you have 0.18 mole per dm cube of SO3. You also know that you have 0.12 mole per dm cube of SO2. And from what you calculated, you have 0.75 mole per dm cube of oxygen. Now here, from 0 to this, you know it has increased by 0.18. So 2 SO2 corresponds to 0.18. Therefore, 1 will correspond to 0.18 divided by 2, which is 0.09. Which means that whatever value of B you have, this will decrease by 0.09 because mole ratio is 1:2. Here, 2:2, so this is going to decrease by 0.18 itself. So A minus 0.18 is equal to 0.12. So you can find A. So you just add the values. And then B minus 0.09 is equal to 0.75. So you can find value of B. So this is the answer. Sorry, this is 0.3. And this is the answer.